We introduce artifact-based rendering, a framework of tools, algorithms, and processes for creating more expressive and engaging data visualizations. Artifact-based rendering starts in the real world with traditional tools, including painting, sculpting, and even finding inspiration in nature. The theory is that the richer visual vocabulary can not only help us depict more data in our digital visualizations, but can also produce a more natural aesthetic that reaffirms the human connection to data and science, something that is often missing in our communications today. Stage 1 of artifact-based rendering is crafting artifacts. Stage 2 involves digitizing the artifacts with 2D or 3D scanners, and using applets to translate them into 3D graphics-ready assets. The Color Loom applet helps artists weave together colors from a variety of digitized artifacts to produce continuous color maps. The Infinite Line applet takes an example as input and synthesizes a longer, seamlessly repeating texture in the same style. Artists adjust the parameters in real time until they get the line they like. The Texture Shaper applet crops and resizes textures, and optionally generates normal maps. The Glyph Aligner applet associates forward and up directions with 3D artifact scans, and computes a series of simplified meshes and normal maps for fast level of detail rendering. The final stage of artifact-based rendering is building up a data-driven visualization in layers. Our implementation supports 4 3D visual layers. For example, the oriented glyph layer. Layers are defined with a 2D interface that provides hooks for the artifacts and data objects used to vary their position, orientation, color, texture, or other visual properties. Here is an example of several glyph viz layers used to visualize the distribution of nitrates and carbon in the ocean. These glyphs are distributed and colored according to the variable concentration. They are oriented according to current direction, and their aspect ratio is driven by the velocity. Here is an example of a line viz layer applied to water velocity streamlines. The textures on these lines differentiate between cyclonic and anticyclonic flow, and the color indicates the amount of curvature in the flow. Here is a surface viz layer showing an isosurface of temperature equaling 26 degrees Celsius. The changes in texture indicate salinity, the color shows current velocity, and the cutaway mask indicates high presence of oxygen. And a volume viz layer can use an artist-curated color map to show velocity magnitude across the Gulf. Artifact-based rendering makes it possible for non-programmers to create high-end scientific visualizations of VR environments, and the potential to enable richer visualization design processes. Here's an example of the type of visual variation that is possible from a day spent working with a traditional scientific visualization tool like ParaView. Here's an example from a day designing the same visualization using artifact-based rendering. After some more time refining the visualizations of the macroalgae in the Gulf of Mexico, an artist can produce images like these. And the same process can be applied to a variety of additional multivariate volumetric datasets, like diffusion tensor imaging of the brain.